Hi everyone, my name is Dean and you're listening to the MLOps podcast. As you probably know, machine learning in general and data science are two fields that are evolving all the time, and it's really hard to keep up to date. Specifically, the area of bringing machine learning into production or into the real world seems like it's very confusing. There's a lot going on and it's hard to make sense of all that's happening around you. But on the other hand, there are a lot of smart people that are doing great work in bringing their own projects into production. And we've had a chance to speak with a lot of these people, but it definitely seems like the information is not widespread enough and a lot of people don't know of best practices and how other teams work. So that's why we decided to start this podcast, where we'll be speaking with people who are working in various types of machine learning teams and hearing about how they are bringing their projects into production. I hope you find this interesting, and let's get started. Today I have Urszula with me, and we're going to be talking about data science in general and data science in production specifically. So Urszula, thank you for your time. Let's get started. So Urszula, can you maybe introduce yourself to the audience, a bit about your background? How did you become a data scientist?
Sure. Hi, Dean. Hi, everyone. So I'm originally from Poland, but I moved to France when I was 19, and I studied for my undergrad the double major of biology and mathematics. And then I continued with a master of interdisciplinary science applied to life science. So this prepared me to actually do some sort of computational work, so programming and statistics, to apply to healthcare and some sort of biological problems. So I continued with a PhD at the Cancer Institute here in Paris that was also around these topics. And what we call this field, we call like systems biology or computational biology. So probably most of you never heard about this, but it's mostly using software and programming to solve biological and healthcare problems. And after that, I decided that I want to try something else. And maybe the biology is not the most important factor in the things I do, that the things I really like is programming. And I decided to try a new type of career, which is data science career, which is still quite emerging discipline. So I prepared myself for that, doing some data science bootcamps, adding some skills about big data to my CV, and then I landed my first job. I actually signed the contract before finishing my PhD. It was a data scientist position in a startup working on optimizing budgets for big companies. And after quite quick time, I realized it was not really a fit. And I moved to another company, which was a consulting company in general in digital. I was in a data science and data pole in general. And this is where I started to really work as data scientist properly and working with machine learning. And I learned a lot about the corporate culture and what is expected from a data scientist in companies. And after a 1-year adventure in that company, I moved to my position I am now, working for a public institution with NLP.
Oh, really nice. So that's super varied. I guess another question about this is one of the challenges I hear from a lot of data scientists is knowing how to find your fit, whether you're one of those people that will enjoy academic research more or going into the industry. And if you're going to the industry, then there's obviously a bunch of different options. And it seems like you covered a lot of them. So it would be interesting to hear what were the signs that you should transition to somewhere else, and what tips can you give to people who are not sure whether the place they're at is the place that they should be?
Yeah, so I had a lot of discussions with my friends that as me, they did some science, they did PhDs, and they kind of say what to do then, or they engage in a postdoc and they don't know what to do. So what I observed myself, that most of time it's very hard for people that actually want to stay in science, but can't stay in science because of problems, more technical problems like fundings, like lacks of positions, and then they want to move to industry, but it feels like they still rather would like to be in science. It's just impossible for them. And I think these profiles, it's quite hard for them to move into industry, because when they present themselves, it's a bit like, yeah, I want to join your company because I cannot do what I love. And this is probably a bit hard. For me, maybe I'm not the best example, because since my master's, I kind of knew that I don't want to be a researcher, and I want to go through these different steps of being a postdoc, going to another country, coming back, writing fundings, papers. It's more like I always saw my PhD, I saw it more like a job that opens a lot of opportunities for me, because I could form myself during my PhD. So it was a paid position, but at the same time, I could have courses, I could really make my curriculum as I wanted, so I could prepare the next step, instead of just getting a master and then going to another master. Maybe data science master would also be an option, but I just chose the option that was more practical for me. And of course, I enjoyed my PhD, but I already saw it as a step through something else. So I think it really depends on yourself and what you want to do. And the thing is that often people are forced to go some way because of some other circumstances like finances or life choices, like family, friends, love. And this is where they are kind of lost, because they want to do science and they end up in company. And yeah, it's quite a different world to function, and there is a need of adaptation of the moral mindset than skills, actually, I think.
That's a good point. I think so basically what you're saying is, like, if you can prepare in advance and make sure that the thing that you're doing right now is sort of moving you towards multiple options so you can later choose, that's one point. And the other, I agree, like I think a lot of people don't realize how lucky they are that they can choose to go in one direction and not the other, or have more than one option. But yeah, I guess it's one of those things where preparation gives you the extra options later. So that's awesome. Thank you. And so I guess today or over the years, what types of data science or machine learning projects do you specialize in? Can you give some examples of the projects you've worked on and maybe business outcomes, so how they affected the bottom line?
Yeah, sure. So when I worked my PhD, I used to work with mostly with numbers and huge matrices that would not make much sense to anyone like just reading them. And that was the point of my PhD work, is to get some sense out of these huge numbers. And so this was the main point of applying sort of seek-to-seek algorithms that we would now use it as sort of autoencoders that would change the signal that you put in and get something more meaningful out. Since then, I wanted to apply my skills. The skills was basically maths and stats, and then the machine learning was sort of it was not actually the main thing I was doing, but I knew I had the skills to learn it. So I was learning it on my side and doing some small trivial projects with classification and regression, and that all of you probably seen and using scikit-learn. And thanks to this, then I started to work with different projects. And in my in the consulting company I worked with, one of the projects was, for example, working with the interpretability. So maybe you call it about the SHAP framework. I had to create sort of a hands-on guide for SHAP and what's going on behind. And this was one thing that I really liked, and I actually wrote also a Medium post and the blog, not the blog, a book chapter recently, data science in tourism, that I was asked to write about interpretability. So it's not yet released, but it will be. And then the last thing that I tried in my consulting firm that I actually put me put my interest to the point where I'm now was the NLP. And this is what really was really new, and I was put into this project like, oh, let's do some NLP. And I was like, I've never done any NLP, and you're sending me to a client with huge projects on that. And then I was really surprised how well it worked. Like I tried for that project, I actually tried very sort of a simple solutions. I use like Spacey, that you just read the guide and you put some data in and you have results, and it was really great. And I was like, wow, I really like it. And this is why I started to dig in to actually learn the NLP that is working with deep learning and let's say more low level NLP and everything about it. And this is how I decided that my next career step will be the machine learning engineer and specialize in NLP.
Okay, wow. So that's super interesting. That's actually, it raises a point. So explainability and interpretability, I feel, is one of those topics where it's raised a lot of times in a lot of different conversations as something that we need to get better at. And I feel like most people know SHAP and Lime, at least by name, but on the other hand, they haven't really used it. Or if they used it, they only used it like in the default view of like, let's print out, let's throw in the input, see the output, and then hope for the best. So I guess maybe from your experience, what are the extra steps? Like where, what do you think about when you're solving a problem that you know you're going to have to explain to someone else? And maybe specifically what happens when that someone else is less technical. So I think that's also an interesting question to a ton of people.
Yeah, so I think these frameworks, they have, let's say, double used. There's one for data scientists that can be helpful for debugging. So especially if you work with like quantitative data, so I see it really useful for like matrices with where you have lots of numbers and then you get some prediction of like classification or prediction in regression, and you don't know where this prediction come from, and in some it happens often that this is corrupted by some features that are more important than others, and they totally bias your model, and you can realize it using this kind of solutions of explainability, because they show you which are the weights of different features, and you can also use it to control the model to make it less biased, and also to have features that are consistent, because you can see what's the impact of each feature on the outcome. So for me, this the first part is the debugging, and the other part is really the communication for the stakeholders, I don't know, your supervisors or people that are less technical. And this gets quite tricky, because when you work with a model, often your unit space or your variables are transformed. You normalize it, and you get like with age between -5 and +10. And then when you get apply this interpretability frameworks, you actually use those data, because probably you don't even get the access to the original data, because it's going somewhere in the pipeline, like in big companies when you have the ETLs, well, or you need to make a huge extra effort to get this data and to get back to that data. And all this interpretability framework, some of them allow you to add some additional data that will be just the data you will plot, use for the plots. And this is something we don't really talk about when you use these tutorials for SHAP or Lime. Everything looks neat, and they use the data that are not transformed, or they already have the other data. And when you go to your boss and you're trying to explain that with the age -5, you have best prediction, and or the group of users means -5 and -1 age, he would be like, what are you talking about? Like, it makes totally no sense. So yes, for your model makes sense, but for people it doesn't make sense. So that's another like step we often forget to talk about, that you really need to make the interpretability understandable for human, not only like not only true, but also understandable for human. And this is, I think, something that is not really obvious, because some of people work with the also machine learning as a service, like many things, and some of the interpretability frameworks, they need actual model to interpret. So I think it makes a lot of little problems that are quite not practical to use it in like every day. And I guess for simpler models like scikit-learn, there is no problem. But then when you get some more custom, you need a lot of extra work to actually make it work. So I think this is why most people like they don't use it too much. And however, some of them are obliged, like in banking, there is some regulations that require them to show. So at some point, sometimes they would just go for an easier model, the model that is simpler and that has less performance, because they will have less problems with it at the end. So yeah.
Yeah, that makes sense. Yeah, definitely. It's a common occurrence where you want to use that shiny neural network, but you're going to use a decision tree because it's much more explainable. And in the example that you gave, so you would use SHAP to explain the model to yourself, and then you would need to do some sort of a buffer step before you explain it to the rest of the stakeholders. Did you use any specialized tools for this, or is this more of like you do some post-processing with Python and then create a PowerPoint presentation to show the rest of the team?
So in general, when you use if you scikit-learn and you use pipelines, you can somehow go back using the pipeline to the original state of the data. So this is when you actually control the full pipeline is okay. I actually wrote some wrapper functions for SHAP that would accept what I call display data, and it would use those data to display on the plots so that it would do it automatically. So, well, I think with some scripts you can do it for scikit-learn. I never try to really use it with deep learning or with some more exotic frameworks, because I already saw it like a lot of development and I was never really asked to provide it. It all depends on the projects, and sometimes you do it, you want to show that, oh, this prediction is because of this, and they don't actually care because they just want a good prediction. So all depends on the type of a project and what is needed. So yeah.
Yeah, I think the way someone told us is that the first part of working with non-technical people is you need to help them understand what they want out of the technical project, and then you can start providing what they need. So definitely. So maybe can you tell us a bit about your current role? What types of problems does your team solve in the organization?
Sure. So I started my adventure with NLP working for a pharma company that wanted to upgrade their capabilities to analyze patents. And what they needed is to find automatically the molecule in let's say chemical or biochemistry patents, the molecule that is targeted by some drug. And they also want some classification, but mainly this task of finding the target of a drug was quite challenging, because it needed to not only identify the molecules, different chemical molecules, but also find the one that is the targeted one, because there's always the recipe and a lot of molecules, and then how you find the one that is targeted. So from the NLP point of view, this is called named entity recognition task that allows you to find some words in the context. So for example, you can have different names, and because of the context, it will help you to identify the one you are looking for. So it helps, for example, if you're looking for first names or second names, and they have the name of a common object. Let's say someone is called Mr. Glass. And this kind of approach allows you to find that a glass is not just a glass, but the glass is the family name, because of the context, and because it's written differently, and before this you have a first name, and after this, it's just the context. In the context is different. So now I'm working in a very similar project. We are working also with long documents, and we're trying to identify some words in the text that will be then removed from the text for the official publication.
Interesting. So this is a problem sort of with, especially the pharma example, is a problem which is maybe counterintuitive, because you're working on, it's not plain text. So usually when people think about NLP, they think about speech, but here you have like scientific notations and things like that you need to understand. So I'm guessing that there are less solutions for this when you're looking for things online. Is that correct? Or did you find what you needed?
So there is actually, even when I worked on this, it was the beginning of BERT, and there was actually even coming out the BioBERT and the SciBERT, which were actually trained on the scientific documents. So it is not that uncommon because there's active research on it. So you still find the things that are really applied. I was lucky that the patents were actually in English, because I guess when you try to find something that is specific to scientific literature, I don't know, in philosophy, in a specific language, in Greek, then you have more troubles to find it, because, well, we are quite depending on the community. Of course, if you retrain your let's say BERT and you create your own BERT, you can do it. Now even it's easier because you have Hugging Face and a lot of scripts that help you to do it. But it's always still requires a lot of hardware, and it requires a lot of documents, and it requires another step that can make time and cannot work out. Is, of course, when you work in English or some other languages that are quite popular, maybe German, it's probably easier than working with some more exotic languages or very narrow disciplines.
Yeah, that makes a ton of sense. Okay, awesome. So let's maybe talk a bit about machine learning in production. So obviously you can split the workflow of an average data scientist into two. You have the prototyping stage where you're working alone, you don't care about the outside world, and you're trying to get some initial result. And then you have the moment where the rubber hits the road and you actually need to take that prototype that you worked on and take it to the app the company is building or to the users that are going to use that API or whatnot. Can you maybe share a bit about your thoughts about how that is done? So how do I get my machine learning project from the research phase to production? Do you have an ideal pipeline or stack that you use?
Yeah, so in my career, I worked a lot with POCs, so proof of concepts, and I need to say you could see that there was a lot of things we were doing and we were testing, and it was in sort of closed environment, and there was no vision how to put it in production, actually. Sometimes there were actually no vision how people were supposed to use it, like interface. It was somewhere in the pipe, maybe in 5th step, there will be some interface. I think this kind of things should be designed like from the start. I'm not saying you cannot do a POC and then, but at some point when you're really interested in the project and if the POC is working, you should have a plan how to put it and in the environment. And I think the thing is that these kind of models, the way they will be constructed, they not always answer the needs of the final user, because maybe the final user needs to be able to put some parameters, additional parameters, or have a sort of a display you are not providing. And this is really the front, but sometimes it can impact the actual model and how it works and what it shows. Maybe the user needs explanation for the words or classification, and then you need to that does it, and maybe use the model that it cannot be interpretable or doesn't work with any known framework. So then you will need to change everything from the start. So this is one point. Another point is that I think what makes it easier if you really have a data scientists work with developers or data architects, and they know what's the infrastructure, and also the developers from the start discuss with data scientists what sort of infrastructure can be used. So should it be API? Should it be an application that is integrated in some bigger structure? Personally, I'm normally working with APIs, like FaceTime API is very easy for data scientists to make. It's easy to send requests then from any other program in the system, and normally there's not many conflicts because the system is quite simple. I probably never work with some more advanced architecture, like events that are triggered or really a real-time need of quick response. I usually had, let's say, a flow that had some certain time to be accomplished, but no pressure that the answer needs to be done in like a few seconds because the user is there. Usually it was the part of pipeline that was more in the back end with no much pressure on the time. And so I think the most of problems from coming from development to production is the communication also between the different teams. The way that it happens that data scientists, they are kind of isolated from the others, because maybe they work from external company, maybe they are not, maybe they are coming just for one project, this specific project, and then there is like, wow, this old platform is not prepared to accommodate Python. It doesn't have Docker and a lot of other things. So yeah, this is a big problem, I think.
Yeah, that makes a lot of sense. And then, so from all of the tools that you've used, is there one that you can't live without for your production or work in general?
I think in general is the Git. Git is good for developers, for data scientists. Interfaces like GitHub allows to communicate, to make issues, to discuss, and it's all in one place. And this is kind of standard to work with all the technical teams. I think this is good, but even in my it depends, because there were still organizations that they did not use Git. So well, this is kind of hard to understand nowadays, but it exists. For me, it's really the must. It's the minimal. Then other tools is, of course, to use some good code editor that you can do debug, that you know, and also simulate some different platforms, be able to, or at least the platform you will use for production. Also to have, of course, the development server and the one for production, because you cannot just throw it on the production one and break everything. So it seems, I think for developers it's like obvious, but I think lots of data scientists sometimes they work only with the Jupyter notebooks, and then how to put it in. I know that, like, I think it's Netflix, or I don't know, which use a lot of Jupyter notebooks, and they use this in production. Well, I'm not really convinced is the way to go. I was using a lot of Jupyter notebooks in the early stage of my career. Now I use it, I would say, rarely to just run some demos or very quick analysis. And then for on the data science part, I think it's also important to keep track of the versions that you put in production, to be able always to go back, because sometimes everything goes back and just everything goes wrong, and you need to just get back to what it was because it was working. So you need to know what was the changes you made. You need to be organized. You need to use. It's better to use some sort of production tools. And also to version in your models, in your code, as you would do now with DVC and or other like MLflow probably, and then you can use it to have a history of your developments.
Yeah, that makes a lot of sense, and I might be biased, but I definitely agree with everything you just said. So with respect to process, so let's put tools aside for a moment. Obviously, like you said, maybe coordinating the process from that we're going to use to take our work from research to production is important. But have you sort of, with all the experience you've gained in the different areas that you've worked in, have you converged into a well-defined process? Like if you tomorrow start a new project, how are you going to make sure that it gets from research to production?
Well, I think first thing is that you cannot do it alone. I think it's the production part really depends on many other people often. So of course, if you want to make your algorithm served and to be used by a wider public, you can choose like a web app. Maybe you can have a control over full pipeline. If you are working in organization, usually production is not really up to you. Well, it's not up to you when it's gonna be done and how. But I think that generally the pipeline, if I have a totally new project, it would be great to have the remote access directly to the servers I will deploy. That's really helps a lot. To create the virtual environments that I can control exactly what kind of packages and the rest is there. And then I would create, starting probably from some template, a new project. I will start to work on it. I will push it to Git. I will create the branches, and then once these branches are fine, they're tested and really tested and ready, I would do some another, let's say, application test, integration test, and then it would go to the productions if the performance is satisfying.
So can you tell me a bit about the team structures that you've worked in? Were there data engineers, analysts, domain experts? How was the work divided between the different sort of job titles?
So yeah, it all depends on the projects. I often worked either as a only data scientist or with another, at least one data scientist, plus some developers that would take care about the interfaces or a bit of the databases, like calling databases, or at least serving APIs so that I can easily call the data or get the documents. Or sometimes I would just use some simple SQL queries. Usually I've worked with environments where the databases were already there and I just need to call and the data. Or I worked with the documents that were directly on my computer, usually for the proof of concepts, the smaller projects. So then I didn't need to really organize it a lot. So I actually never worked with the proper data architects or data engineers, because I guess this work was already done when I was arriving on the project, and there was only the database maintainers or responsibles and the developers. And I also used to work with designers in some projects when the project was in development or there were some new features that were coming. They would work mostly with developers for the interface part or the well, mostly the interface, because always it was about the users. And also the part of the team that you cannot forget are the people that are not technical, that are actually the people that either are the managers, either they are your project owners, and you need to communicate with them. And I think this is the part that is a bit challenging, because you are not used to the tech communication ways that we use. They would not be so easy to communicate with them on Discord or Slack or the Git. You would need to send emails, or well, there is a thing that you need to make it easy to use also for them to participate, to make them participate in the communication, and it's not always easy.
So did you end up solving that with some familiar tool? Like, for example, you could use issues, right, or something like that. It does has its downsides. Obviously, it's not as responsive as like using Slack, but how did you solve that?
Yeah, I think most of time they just send emails, and then this is translated to GitHub issues by the technical team. At some point, you cannot request, and if it's not the general politics of the company, or you cannot impose your communication ways. I mean, you can try to make them work together. They can communicate the best they can, but if they have sort of a barrier to use Git, well, you cannot force them, and it's not also productive to actually do it.
Yeah, that makes sense. Actually, I guess that there's a feature request here that you could send emails out of GitHub, and when people respond to the emails, they get a comment in the issues for you.
Yeah, so, that would be great. Yeah.
this is an interesting idea. And how about sort of building up? So one of the roles that we see more often recently is like machine learning engineer or MLOps engineer, like someone who's responsible for setting up the infrastructure for the project. Do you usually do that yourself in projects that you work on, or are there developers or maybe DevOps people that are assigned to the project and do that for you?
So I think definitions of the names are also quite blurry, because for me, machine learning engineer is like a data scientist that works with machine learning actually, because data scientist now is more like a, well, some people put in there data analysts and more like BI and everything actually in data scientist part. So for me, machine learning engineer is more like someone who actually does machine learning development and engineering of models. But I see what kind of role you're talking about. It's more like I think I saw some job posting about this. It's more like maintaining ML projects. So you take care that they are clean, that they are well tested, that they run correctly, and that they are well structured. So for now, it was totally up to me to make it that way. And most of time, there was no really like a quality review of my code. Which is kind of, well, I think if I were working in a bigger tech team, it would be definitely something that would be in place. So far, I was usually a solo data scientist or with one other person, and with no, the only requirement was that my thing works and communicate with other parts of the system. There was no, there was actually no requirements about how it should work, and yeah, I think it depends on how mature your environment is, and the company and the team you are working with, and what is the scale of the project. Because well, if you're building a massive things that would be released open source or cover like a huge organization, then probably you would really need such a person to make all these different projects more homogeneous. Because then I'm doing it in my way, my colleague will do it in his way. We can still talk to each other, so we will understand. But when you have 20 data scientists, everyone doing different types of project templates, then I guess, it's a really a mess.
Yeah, definitely. The scale affects how sort of specialized you get the team to become. So that makes a lot of sense. So can you maybe name some of the most interesting repositories and tools that you've worked with recently?
Yes, so I work a lot with Flare, which is a quite popular framework in NLP, especially for NER. It's quite easy to work with, and when you want to add some features, you create like a pull request, and they usually quite quickly integrate it in a new version of the software if it's right. But another philosophy of working with like a growing NLP software is Allen NLP. Because sort of it's like another layer on PyTorch that helps you to do some stuff that is pre-programmed, and you just use one function, but it allows more of plug and play. It uses a lot of formalizations like config files and some templates, and then you have you can just use it as it is. There are some models that like zoom models that you can use. You can also take some project and you can try to change some parts, like change word vectors, or change the network that is used, or some add some layers directly using PyTorch or write your own model, but just use the data import as it is. So this is another philosophy, because it's you don't need to ask a pull request from them. You actually have tools that allow you to develop your own like add-ons to what they created, and to play with the system in a plug and play way. I think it's interesting. It requires a bit of time to actually learn how to use it. Sometimes you would say like, I would just do PyTorch, because if I need to rewrite everything from scratch anyway, then I would just do PyTorch. But then I think this kind of structure makes it easier for other people to understand what was done. And also, if yourself you want to change just a bit of code, normally it should be easier, because your code is written in a more structured way, and it's prepared to do some changes and to accept those changes, and it will not really break just because you forgot to transpose a matrix or something. So because you have predefined outputs and inputs of each step of the pipeline, and you need to stick at least to this. This helps you to structure, and also it forces you to structure your logic. You need to imagine like compartments of your pipeline, like data import, data processing, and then the actual model, and then what is out, and then the prediction, and it helps to organize. Yeah, I think it's the most important part of this.
Mm-hmm. This field has a lot of things going on. Again, you said it yourself, it's an emerging field. There's new updates every day, both to the tooling and to the sort of research. how do you stay up to date? Like, what tips do you have for people that want to be on top of everything?
So I received tons of also newsletters. Sometimes I don't even have time to read them. I have some people I have on my list in LinkedIn or Twitter that often posting the things that are interesting. So I can see some new stuff. This is sort of a passive learning. When I'm trying to find some new interesting stuff, I would use Papers with Code, which is a great repo because great website that helps you to find not only the scientific papers but also the code that's associated with. And from my experience, actually, the papers without the code, they are not really, well, I probably will not use them because I will not have time to re-implement what is in the paper directly. So having the code already there helps me to understand the paper also, because I can actually see what was going on. And I can sometimes test it. I can see the type of data input, because it's not always really well explained which kind of files you will put in a scientific paper, because this is not like the most essence of the paper. But for my work, it will be the essence that to see which kind of files are there, what are document types, how they are structured. And so this is, for me, is very important. There was also a really great newsletter from DaresHub, but it stopped in August 2020. They were doing like paper summaries, like a newsletter of all events and stuff, but it's a pity it's not there anymore. And I'm also following the releases from some main libraries I use, like Hugging Face, Flare, Allen NLP, so that I see if they added new models. I'll probably see, oh wow, this new model, I will need to read the paper about this model to know why this model is useful. And this is also the way I learn new stuff.
Yeah, that's awesome. We'll add some links in the description afterwards. So if people want to sort of join the following, they can do that. So what do you think are the biggest challenges for you in data science and machine learning?
So I think that the biggest challenges is the organization, because for me the data scientist was sort of at least some years ago was sort of creative chaos, that people were coming and then starting to try new stuff. You can see it like when you look at Kaggle projects, and like exploring and trying different models, and then trying to do some hyperparameter tuning, but then maybe not. Maybe you need to start from data pre-processing, and like it was like creative mess. And now I think when we try to really use machine learning models in production on the bigger scale, when other people trust that this is the solution to actually adapt, we need to make it more organized, more robust. And because we are responsible now for the outcome and also for the way how it lives over the years. So testing 10 best models at the moment is not a problem, but what if your model needs to live in there for 5 years or more? You need to have a way to test new models all over the time. And this is where actually, for me, DVC, creating DVC pipelines was like really a game changer. I can then use an interface like DagsHub to see the results, and I can do it 3 times a day. I can do it once over a month. I can have the results in one place and see how the model evolves. If I want to replace the existing model with the new one, and I also can, 3 months later, I have a great idea about the model I was testing before, and I can go back to the parameters I used. I can just change the parameter or the input vectors at that moment, and then I will see the result. I don't have all these tons of files, version 1, version 2, version 5, that are then overwritten because I forgot to change the name. I have everything in Git, and I can easily go back and play with this. And this is really good for the organization over time, because I don't know, I tend to forget, like over 2 months, if I didn't work on a project for 2 months, I don't really know anymore where the files are or what I was doing. It's I need to like start over to to get back where the things are. And when it's organized, it's easier. I think it's like with everything in any profession, every profession, when you have your files organized, like even like physical files, and you know where to look for, you can go back easier to your work.
Yeah, I definitely agree with that. The most common type of collaboration in data science is you with future you. So you need to make sure that you're preparing something that your future self can actually understand.
Yeah, exactly.
So what's your favorite and least favorite thing about being a data scientist, if you had to choose?
So one of the most favorite thing in data science is that how much space and possibilities in creativity you have, because with all these new projects and the new stuff and even the existing stuff, there is so many possibilities to test, to change, to modify, that you probably will never get bored. I mean, you can get bored because you will try so many of them that you cannot do it anymore. But it's never over. Actually, it's never over. You can even say to someone, yeah, I tried this and I didn't really work, and you heard about this framework, it worked really well for me, and then you need to start again because it's a new hope. And this is really, really great. And also that this AI, some of the AI applications, they really change and automatize the really boring tasks for other professionals, like the classification projects. Instead of having a human classifying files, you can just do 10,000 files in a few seconds. And this person can do something more interesting with his life, like even not really thinking about him losing the job, but often it was a part of his job that was taking a lot of time and it was not really interesting. So now maybe he can read the files that are already classified, and he can do his actual job of writing some summaries or some articles or some other things. So I think seeing the impact of the ML work on the professionals is also really interesting. And so now the part I like a bit the least is that the data scientist position is a bit, as I said, a bit blurry in a way, because it's still quite new for many companies and many infrastructures. Is new. They have either tendency to overestimate you or underestimate you. So overestimate you is like you are the magician and you will make everything work. Like they just, I don't know, they send you PDFs and they want you to do something with it. Like, I mean, no, not like this. I mean, it's working with PDFs is a whole other story. But in general, they expect you to do stuff that you cannot do if you don't have the prerequisites to construct a machine learning project. You need annotated data, for example. And many people forget they want you to do machine learning project, but you don't have any annotated data, and they don't want to pay to create this resource because they think it's your job to do it, to make it work. And no, you can't. Without annotated data, supervised learning doesn't work. And so this is a part of it. And also sometimes because there is a huge hype around the data science, organizations will hire data scientists and then they will think what he or she will do. And this is really disappointing because we are formed, and most of us are very enthusiastic about this, the work we'll do. We really want to do great things. And then we are asked to just watch and wait, or organize files, or write some bash scripts, on administrate the environment, because they don't know what to do with us. So they just put us something with IT. And this is really disappointing. And probably you could see, like many of other people, this kind of job postings that are asking you to know all the frameworks, like cloud frameworks and PyTorch, and then Office, and then emails. Like I saw this kind of things, like what are they talking about? They have no idea what they're talking about. And also you need to have a PhD to do some means and to calculate averages and the month flow of the data. Like no, like you need to find a match for the job. You maybe not need a PhD if you have some simple tasks. Maybe someone who wants to learn, and then he will evolve. I think this is in general for HR, that's the greatest challenge, is to to find an employee that can evolve in his work, he can enjoy it, and we are not all with the same professional goals and expectations. So
yeah, that's a good point, and I think it's obviously a case-by-case basis, because if I go back to the first question we discussed, it's basically everyone wants to do different things, everyone has a different fit for the organizations and the work that they're going to do, so you need to adapt the work to the person who's doing it. I guess one question that comes up here is, let's say someone is listening to this and they're exactly, they heard your answer and they think, that's me. So do you have any tips for how to handle that? Because obviously, if you're a data scientist in that position, that could be being between a rock and a hard place. Like if you complain, then maybe you're worried of losing your job. But on the other hand, maybe you shouldn't be in a job where you're working on something that is not really your skill set.
So I think it's the first thing is to evaluate in an objective way the possibilities in the company. So if there's something I can do in this company as a data scientist, if there is, why I'm not doing it. Maybe you need to add additional resource, or maybe you need to make understand your managers that that you want to do that thing and this is the thing to do. So evaluate if there is a way for you to evolve in this organization. If you find that there is no, and they always keep on telling, oh, there will be stuff to do next month, next 2 months, next 3 months, probably they won't be, or they will be, but too late. You will be already fed up with what you do. And I think, I don't know about each country, but I think in most of countries, there's still lots of data science postings in general. So we are not that stuck. I mean, most of time, you can change your job for a different one if you are really not seeing opportunities to evolve, because you can also see it as that if you spend lots of time in a job that you are not doing anything, you are not keeping up with your competition, with other people that were at the same level as you, but they are doing actually the data science thing, the things you want to do in your career. And then you go for a job interview in a year, and then you will see what I was administrating the system. I was using Bash. I was writing Bash scripts, and now I want to do machine learning. This well, it's not very coherent. So I think people should not. Well, I think it's always hard to make a change because we feel like, oh, it's I really wanted this position because you went there for something. Probably they told you you would do something else, or they promised you that it would change, or that you will bring the change. So you try to put the guilt on yourself. It's important to explore and evaluate all the possibilities in the place you are, because it's always good because you're already there. But if there is no option, there's no option. You just change. I think it's now we changed. I already changed 3 times the job since the end of my PhD. So 3 jobs in 3 years, and I don't even feel like it was that well, not difficult because I had the opportunities, but also not that difficult because it's just normal. That's how the job market is now. You can change if they don't pay you enough, if they don't make you do interesting stuff. You are a data scientist, you are the unicorn, you just change. we are lucky because not many professionals can do it, so we should use it.
So the takeaway is data scientists are unicorns. I like that. So that's I mean, but I agree with everything you said. I think that makes a lot of sense. So any good papers that you've read recently?
So I'm quite interested in following the information about how to work with transformers for long documents, because it's true, I find it that is really a pity that well, lots of people working with like tweets and sentiment analysis, they are fine because they have very short messages to analyze, and they can really take advantage of this new what we call Bertology. All the great models that were released, that they are improving. But for the long documents, it's still quite a problem because there is, well, it's the limit in BERT is 512 signs, I think, characters.
Yeah.
And most documents are longer. And then what you do, first strategy was to cut and just use first or the last or the middle, whatever, 512 signs. But Of course, when you have a document of a few pages, well, you can try to split it, you can try to apply different strategy, but it's kind of a headache. So now there is some solutions that try to emerge that adapt transformers for long documents. So there's this reformer paper. There is some other people trying Siamese networks, and also I think I saw longformer also, that on the papers that is supposed to be for long documents. So I think it's great, but again, when I worked with this with French, there is no, I didn't see at the moment French version of these transformers. So I need to wait. I think the reformer is already on Hugging Face in a, let's say, experimental flag.
Yeah.
So, well, I usually wait till it's in the Hugging Face, until it's tested by some people in general, because I already tried at some point use the BERT or some version of BERT that was released with some paper, and it was not really, let's say, user friendly. You had to dig in their scripts, and it was not really well explained how to use the scripts, and you just waste a lot of time. Maybe if it's really critical for you, you will spend time to do it. But then if it's just to test and see if it's better than some other stuff I'm using and that is quite good, you will wait, it's actually usable. And that's why Hugging Face brought this great revolution to our lives with the centralized repo that you can just use in the same way, calling different models.
Yeah.
It's changed the real lives of in NLP, I mean, also in, I guess, computer vision and other fields. So.
Yeah. Hugging Face is definitely a revolution which is happening under our feet. I had a bit of experience working on the reformer paper as part of the reproducibility challenge that Papers with Code and NeurIPS ran this year. So I didn't do most of the work. It was a bunch of people from the Fast AI community, and I just joined and helped where I could. But I feel I definitely understand the point you're making. Like, if you go to the paper repository on GitHub, you usually have to invest a lot of work to actually have it running for you. Hugging Face sort of abstracts that away. I mean, someone had to go through the effort of actually doing it for you once, but once they do, it's accessible to everyone, which is obviously amazing. So yeah, like, our experience was the same. You try to reproduce the result, and then you have another issue, which is these models are reasonably like the resource they require are reasonable for inference. But if you realize that you need to change the training process, training a reformer from scratch is very expensive. It's not really accessible to the average data scientist. So that's kind of a shame. But maybe we'll find more efficient models in the future. I know that there are some papers in that direction as well, but definitely that's still the minority. And then when you add like new languages to that, that's even more complicated. So I definitely understand what you're talking about. So how about tips to improve different parts of the data science workflow? So maybe I'll raise a few parts that probably every data scientist stumbles on when they're working on a data science project. And how would you recommend they improve their work on that front? So let's start with model performance, thing that every data scientist cares about.
Yeah, I think it's that one of errors we do is to think that the gold data is gold. You never trust your data, and often the problem with performance comes from the data. There may be mislabeling, some sort of other bugs on the import that make that actually the model cannot do better, like average model cannot do better. And I often fixed lots of problems, and I really changed the performance, just going back to the data and seeing that there was actually obvious problems with the data. And that's why also the good point of working with text, that I could actually see is text in English or French that I can read, that I actually see that was mislabeled, because maybe it was in Chinese, I would never find out. So that's the part that you actually need to know the data, or have someone who will administrate it for you with the goal of machine learning. Because if it's annotated by humans, they might be errors, and they have errors, this data.
Yeah, human error. That's definitely one of the biggest problems. So how about versioning and experimentation? How can I improve that?
So for me, the Git, the DVC, or some other pipeline management, and with an interface such as DagsHub, it's really a game changer. You are getting organized. You put some effort to make it organized in the beginning, but then it's just reproduced over and over, and you are really happy when you have all your experiments in a table automatically generated. So yeah, this is really great.
And how about moving to production? How can I make that easier for me?
So I think it's the communication and communication and collaboration with all the impacted teams, and also the study of the impact on the whole system. You need to know which other applications your application will affect, because sometimes you don't even know that changing something will change some other cascade of events that will provoke a cascade of events that you cannot expect because you are not informed about. So you need to talk to other people.
Communication is key. And
Yeah.
any other recommendations you have for the audience? If I'm a data scientist, something I should take away, or maybe not a data scientist, I don't know, in general.
Yes, I think it's the important point is that this data science machine learning is really a community, and it's important not only to take but also to give. So if you're doing something cool, like share it, write a Medium post, just release your code on GitHub or some gifts, because it can be really useful for someone who is learning or who is stuck. And you don't even realize because you think it's easy to do and everyone knows, but sometimes no, sometimes it's just by chance someone will end up seeing your code, your writing, and it will be a great help. So be curious, explore, and give back to the community.
That's a great point to finish on. Urszula, thank you very much for taking the time to speak with me today. It was really a pleasure. I learned a lot, and I'm sure the listeners will also. So thanks again, and have a great day.
Thank you, Dean. Thank you, everyone. Bye.
Bye-bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again, and see you next time.